Okay, everybody, this is a little video on dynamic range and compression. Let's get started. So what you're looking at is a chart that's going to show amplitude or volume this way and not frequency this way. This will just be time. This will be audio waveforms. So it'll be showing them over time and at various amplitudes. All right. So looking at dB this way, time this way. So here's an audio waveform I just drew freehand. And this is showing, as you can see, in Pro Tools, your peak level is 0. So this would be 0 dB up here. Anything above 0 is going to give you clipping or distortion, which is undesirable. So as you can see, we've got audio that's kind of largely hovering around down here, somewhere around 20, 30 dB maybe, but it's got some peaks in it. There's one here, a couple of smaller ones, real big one here, looks like maybe goes up to 0. Let's label them. So let's say this is 100 dB below 0. And let's say our loudest peak is 0 dB. And the quietest place in our audio measures around minus 70 dB. Okay? There's a concept called dynamic range, which simply means the difference between the loudest portion of an audio file and whether this is a single track in a production like my voice right now or an entire mix of stuff. The dynamic range of whatever that is the difference between the loudest piece of audio and the quietest. So if this quietest part is minus 70 dB, and the loudest is 0, then we have a dynamic range of 70 dB. Okay? It's just simple math equation. All right? That's the dynamic range. You've got 70 decibels of dynamic range here. Let's talk about compression now and how compression makes things louder by first making them quieter, which may seem like a bit of a riddle, but here's how it works. So with compressors, and hopefully you're looking at your Compression 101 handout. With compressors, you can set a threshold, and I'm setting one here. Let's make this threshold be minus 50 dB. All right, so above this threshold, this audio is going to get affected. The peaks are going to get reduced by some ratio that we're going to predetermine. All right, so right now, everything above this threshold of minus 50 dB, whatever these peaks are going to get reduced or compressed at a ratio we're going to set, and everything below the threshold gets left alone. So let's make our ratio 2 to 1. That means for every 2 dB, when you see a ratio like that, the first number is the input and the second number is the output. So in other words, for every 2 dB of increase above this threshold, you're only going to get one, or of input, you're only going to get 1 dB of output. All right, so for instance, let's say that we'll label these peaks at minus 40. Remember, we're in negative numbers, so this is 50 dB below our max clipping point of 0, right? So this is 50 dB down. So at minus 40, this is 40 dB below the clipping point. Here's a big one here. It's only 10 dB below the 0 threshold. Here's one that's minus 30, and then this one goes all the way up to 0. So this one has no room to go any louder. So if we compress this audio at a 2 to 1 ratio, with a threshold of minus 50, that means that all these peaks are going to get reduced by a factor of 2 to 1. So, for example, at a 2 to 1 ratio, a minus 40 dB peak, let's just do the math here. It's pretty simple. This is how much louder than this? Go ahead. I'll wait for you to say it. There you go. 10 dB, right? But at a 2 to 1 ratio, that means these peaks get reduced by half, 2 to 1. So 10 dB above threshold becomes only 5 dB. So now this peak is only at minus 45. which is 5 dB higher. All right. This one, again, you just got to crunch the numbers. Minus 10 above minus 50, that's a 40 dB difference, right? So right now this peak is 40 dB above the threshold, but after compression, it's going to be half that, right? A 2-to-1 ratio. So this will be 20. I think they're labeled on this next side. 20 dB higher than minus 50, right? Which is minus 30. Couple parts in this equation. Let's go over this again. Minus 10 is 40 dB above the threshold. At a 2-to-1 ratio, we cut that in half. So now it's 20 dB above the threshold. So that's your first little equation. Then add that 20 to the threshold. So minus 50 plus 20 is 30. All right, let's do these two together. Here's a minus 30, previously minus 30 dB peak. We say, okay, that's 20 dB above the threshold. Our ratio is 2-to-1, so it's getting compressed at a ratio of 2-to-1. So 20 dB becomes only 10 dB, which is minus 40, because you add 10 to the threshold. And then let's look at this last one, the big peak goes all the way up to 0. That's how much louder over the threshold? 50 dB, right? So at a 2-to-1 ratio, that gets cut in half. It's 25 dB, which we add to minus 50, and we get minus 25 dB. Now let's look at the new dynamic range. Remember previously the dynamic range was 70 dB, right? We had a 0 dB peak and a minus 70 dB softest portion of audio. What's our new dynamic range now? Well, this big peak went all the way down to minus 25. It cut in half. So if you look at the difference between minus 70 and minus 25, you're going to come up with, I'll give you a second to crunch the numbers, 45 dB. So here's our new dynamic range after compression. And this is what compressors do. Compressors reduce dynamic range by reducing peaks over a set threshold by a set ratio. All right? And what's great now, you say, well, why do you want to do that? Well, you know, dynamic range can be a real problem in audio. When you've got huge dynamic range like this, if you're trying to listen to something, whether it's a podcast or a piece of music, and it's got these big peaks, if you set it to where these are comfortable to listen to, a lot of times you'll lose this stuff, especially if there's ambient noise going on. You know, if you're in the car and the windows are down or people are talking and there's just noise around you, this stuff will disappear quickly. Then if you try to turn this stuff up so it's loud enough to hear, these peaks are going to be too loud. They're either going to clip if you're in Pro Tools, or they could, clip in a mixing board or distort speakers. So wide dynamic range can be a real problem. And it's one of the things you're constantly trying to compensate for in audio production, especially in pop music production. So with this compression now, we've got a new dynamic range of 45 dB. Let's talk about one more concept, which is headroom. Headroom is just the difference between the peak audio that you have and the peak level that's allowed. So before we inserted this compressor, we had no headroom, right? Our peak was at 0, and the maximum allowable signal is 0. So we had no headroom. In other words, there's no measure of dB that you could turn anything up. You've got no, that's what we call headroom, right? A little bit of wiggle room to in case there's something louder than what you've got. But now after compression, because this peak is down to minus 25, we've got 25 dB of headroom, right? That means we can turn all this audio up, everything, these peaks and this stuff down here that was below the threshold. And this is the magic of compressors, right? Using that last knob that's discussed in your handout called makeup gain, because we've got these peaks knocked down, we can turn all this audio up, so this can come back up to 0. But now this minus 70 dB is going to be 25 dB louder, right? As we turn everything up. So that becomes minus 45 dB. So what you've done is your peaks are still here, but now your quiet stuff is much louder and easier to hear. And that's how compressors make things louder, by first making things quieter. All right, this next slide, what's going on here? Oh, headroom. Oh, all right, let's try this again now that you got kind of the hang of it. And let's do a different ratio, all right? This was a 2-to-1 ratio, right, which is pretty mild as compressors go. It's about as low a ratio, you could do 1.5 to 1, but so 2 to 1 is what we call low ratio. Compressors can go up to 100 to 1, and then some of them will just be marked infinity to 1, which is kind of like a brick wall. I actually call those brick wall limiters, meaning, hey, once you hit the threshold, basically nothing's happening. There's not going to be any increase. I'm just going to lop it off. But let's do one with a 10 to 1 ratio. All right, so here, new ratio is going to be 10 to 1. All right, so at 10 to 1, again, a little bit of math, this 40 dB, minus 40 dB peak, which was 10 dB over our threshold, right, at a ratio of 10 to 1, for every 10 dB of input, you only get 1 dB of output. So you reduce everything by a factor of 10. So this 10 dB over threshold peak is now only a 1 dB over threshold peak. Got it? This one, minus 10, was 40 dB higher, right? But at a factor of 10 to 1, what does that become? 4 dB. See how much quieter that these have really become. This one was 20 dB over the threshold, so it's now just 2 dB. And then this one, this big one, which was 50 dB over, again, reduced by a factor of 10 to 1, 50 dB becomes only 5 dB. So now these peaks are at, remember, add that, this was 10 dB and now it's 1. So add 1 to minus 50, you got minus 49. This was a 40 dB peak, which became a 4 dB over threshold peak. Add 4 to minus 50, you get minus 46. This one was 20 dB over the threshold, so it's now 2 at a 10 to 1 ratio. Add that to the threshold and you got minus 48. And then this one, the big one, that was 50 dB over, is now only 5 dB over. So this peak is only at minus 45. Let's look at the next screen. So now, what's our new dynamic range? Well, it's the difference between minus 70 dB and our biggest peak, which is minus 45. And the difference between minus 70 and minus 45 is only 25 dB. So now we've reduced our dynamic range from 70 dB to 25 dB. Quite a huge difference. And now our headroom is 45 dB. That means we can turn everything up, right? Our loudest peak is here. So we can turn all this audio up 45 dB, get this back to 0, and now this minus 70 dB quiet spot gets 45 dB louder, so it's at minus 25, right? Yeah, so it's going to be, imagine all this stuff is now way up here. And I didn't draw that, but your dynamic range would look, instead of like this with these huge things, it would be your average level, instead of being down here, would be way up here, right? Everybody in the boat goes up when the water rises. So that's how compression works. That's dynamic range in a nutshell, and hopefully that helps you understand compression. In the next few videos, you're going to see about Pro Tools compression and some other clips I have. This is sort of your building block that you'll build on.